Lesson 2 of our guided notes. During a hockey game on ice, a puck travels 0.75 miles. What fraction represents this distance? So we have the decimal 0.75. We can use, if you remember from yesterday, we used place value. What place value is our last digit in?
Hundreds.
Hundreds, so we can write 75 over what number? 75 over 100. We can simplify this fraction by dividing by 25. And what is 75 divided by 25? 3, and 100 divided by 25? 4. So 0.75 written as a fraction in simplest form is 3/4. We're going over rational numbers today. We will be comparing and ordering rational numbers. Okay, our first vocabulary word is rational number. A rational number is a number that can be expressed as a ratio of two integers written as a fraction in which the denominator is not 0. We have a number bank. The outside ring is rational numbers. So rational numbers includes integers and whole numbers. If you look at our outer ring, there are a couple blanks that we have to fill in. Or we could start at the inner one. What would be a whole number to fill into our inner one? So we have a number bank to the right. What would be a whole number that we could use to fill in? 1, so we can cross that off. For integers, that's what we did in our last unit. Integers are positive and negative whole numbers. So what could we put in our circle for integers from our number bank? -1, so we're going to fill that in here. We have 3 boxes remaining for rational numbers. Rational numbers can be decimals like 0.8. A rational number can be a repeating decimal like 2.2 repeating. Remember that line above is called bar notation, and it represents that we have a repeating decimal. And our last one we have is 1 2/3. Rational numbers could be fractions or mixed numbers. Okay, so moving on in our notes, not all numbers are rational numbers. The Greek letter pi, it looks like this, is non-repeating and non-terminating. So it doesn't repeat and it doesn't stop, which means the numbers keep going on and on and on. And this is what we call an irrational number. Okay, the next part of our vocabulary words, common denominator. A common denominator is a common multiple of the denominators of 2 or more fractions. The least common denominator which is abbreviated as LCD, is the least common multiple, LCM, of the denominators. You can use the least common denominator to compare fractions. You could also use a number line. So if you look at our first example, we want to determine which one is greater than the other. we are given two mixed numbers, -1 3/4 and -1 5/8. Whenever you see mixed numbers, it might be easiest to change them to improper fractions. So we know we have a negative. So if we multiply our denominator times our whole number, 4 times 1 is 4, and we have to do what with our numerator? Add. What's 4 plus 3? 7. So we have a -7 over, we keep the same denominator. And if I change this one over here, this one's also negative. 8 times 1 is 8 plus 5 is 13, and we have 13 over 8. When we want to compare these, we can compare them by cross multiplying and see which number is bigger. This is a trick for comparing fractions. So we can multiply 4 times 13. If you need to do opposite side, you can. What's 3 times 4? 12, and 4 times 1 is 4, plus 1 is 5. So we have 52, but remember they're negative, so we have a -52. If you cross multiply the other way, what's 7 times 8? 56, and it's a -56. Think of a number line. If we have 0, the further we get away from 0, the bigger the negatives. Which number would be the smaller number? -56, because it's further away from 0. So we know that this number is smaller, so we need to use a less than sign to represent its relationship with the other fraction. So we know that -1 3/4 is less than -1 5/8. So when you compare them, we're actually finding the common denominator without rewriting them. And we have -56 over 32. It would be the bigger number, but since it's negative, it's smaller. The bigger the negative, the smaller the number. Okay, for our next question, we have in Mr. Hong's class, 20% of the students own roller shoes. In Mrs. Trevino's class, 5 out of 29 students own roller shoes. In which class does a greater fraction of students own roller shoes?
20 out of 100.
So in Mr. Hong's class, it's 20%. And in Mrs. Trevino's class, we have 5 out of 29. So we are given two forms of numbers. How would you like to compare them?
My decimal.
Okay, we could change them both to decimals. That's fine. What would be 20% as a decimal? 0.20. What would be 5/29 as a decimal?
I have to figure that out yet.
So we're going to have to do, if you remember from yesterday, top dog gets the house. What number is in our numerator? 5, so that goes inside. And we have our 29 on the outside. Zip up your decimal, and then we can divide. Can 29 go into 5? No. What about 50? 1 time. What's 1 times 29? 29, and then we're subtracting. We're going to have to borrow here. 10 minus 9 is 1. 4 minus 2 is 2, and we can bring down a 0. If you look at this right now, one decimal place over, this one is 0.2, and this one is 0.1. We're not sure what. Can we stop here?
Yeah.
Yeah, because we already know which class is bigger.
Obviously,
That one.
the Mr. Hung.
Yeah, Mr. Hong's class of 20%. If he only has 0.1 something, that's going to be less than 0.2. So right off the bat, we know that in Mr. Hong's class, I have the greater fraction. Okay, for our next question, we want to order these numbers from least to greatest. We have 3.44, high, 3.14, and 3.4.
I got it.
So, if you want, we should change them all to decimals. This one's already written as a decimal. We have 3.44. What is pi written as a decimal?
3.141 something.
3.14, that's 159. And then we have 3.14, and the last one is 3.4, and that would be what if we added another digit? 0. Out of these, which one is our smallest number?
3.14.
3.14. What about our next smallest?
3.4159.
Yep, so that was pi, so I'm going to label that one with pi. After that, what's our next smallest number?
3.4.
Yeah, 3.4. And our biggest number was what?
3.44.
3.44. So we ordered these, we put them in order from least to greatest. 3.4 is our smallest value, and they increase until we get to the biggest value that we had, which is 3.44. Okay, so I'm going to have you guys try the on your own questions. This is on the back sheet of your notes. Go ahead and get started on the on your own problems. If you skip ahead to the last 3 questions, the on your own questions, explain how you can compare 2 fractions. Okay, who can give us an explanation of how you compare 2 fractions?
Oh, I learned how to spell denominators.
Okay, you can divide and change into decimals and compare them. You could do what next?
2 common denominators.
You could find common denominators to compare them, or what was the trick that I showed you earlier?
Well, you could multiply it like a cross.
Yeah, multiply across or cross multiply. Cross multiply and compare. Or we said common denominators. Or you could change both to decimals.
Explain how you can compare a fraction.
Okay, for the second part, how can you compare a percent and a decimal?
Put it over 100.
Yeah, you could write your decimal. You could change them to both write them over 100, or you could change your percent to a decimal and compare. Or you could take your decimal and change it to a percent. When you're going from a percent to a decimal, you would divide by 100. If you're going from a decimal to a percent, you would multiply by 100.
This really hurts.
And for the last part, explain how you can compare a fraction and a decimal.
Oh, we did this.
So if we're comparing a fraction and a decimal, what could we do to the fraction?
Turn it into a decimal.
Yeah, you could change your fraction to a decimal. Or we could do what with our decimal?
Turn it into a
Change
fraction.
it into a fraction.
Or change our decimal to a fraction. Okay, so your homework for tonight is to finish the on your own problems. There are 4 problems for you to finish on your own.